Alright, it's section 5.4, the last section of chapter 5. But for your viewing pleasure, I'm actually going to split this up into two parts. So I'm going to have a part 1, and that's what we'll do today. And then part 2 is the video that you'll listen to next day. I'd like us to kind of think back to actually section 4.4. Because this section talks about solving equations and graphs of trig functions, and we did some of that in 4.4 as well. Okay, but we're going to make it a little bit more interesting today, because instead of having just regular sine x or cosine x or tangent x, which is what we did in chapter 4, we're going to spice it up by introducing some horizontal stretches. Yes, that will spice things up. Okay. Now, to help you grasp this idea, I want to show this to you graphically and algebraically. Okay, I'm a visual learner, so I like to see the visual, the pictures. But I also understand we need to learn how to do it algebraically. So I'm going to actually show you both ways. All right, here we go. Let's look at example number 1. I'm going to ask you to solve the following sinusoidal equations graphically first, and then confirm your graphic answer by using algebra. Okay, so I've given you a nice grid. Aren't you glad I gave you a grid? I'm going to ask us to label the y-axis here. Since I don't have any actual amplitude changes, I'm just going to 1 and -1. So go straight up to the top for 1, straight to the bottom for -1. The graph of sine x, once again, looks like this, right? Starts in the middle at 0, at pi over 2 goes up to 1, back to 0 at pi, down to -1, at 3 pi over 2, and back to 0. And we're going to sketch this in. Wow, that was bad. Let's try again. I'm going to sketch this in. And there's your sine graph. Now this is equal to 0.5, so I can actually just draw a line at 0.5. Here's 0.5. And I can tell visually that my solutions are here and here. Okay? Those seem to be, let's see, 1, 2, 3, 4, 5, 6 dashes, so it looks like it's pi over 6 and 5 pi over 6. Okay? Let's solve this and double check that those are the right answers. By the way, we did this question before in section 4.4. So, like section 4.4, you can look back at your notes for this one if you wish. But remember, we're trying to isolate the x, and to get rid of the sine, we take the inverse, or sine -1 of 0.5. You can use your calculator, or you can say this is a special angle. So what reference angle equals to a half for sine? You guessed it, it's pi over 6. So there's one of my answers. Of course, that's not the only answer, and this is a review from chapter 4.4. Remember our lovely ASTC, all students take calculus. And we know that sine is positive not just in the first quadrant, which is what we have, but also in the second quadrant. So we have to actually calculate this angle. And to do that, we're going to invoke the idea of the reference angle and say that, hey, the actual angle in quadrant 2 is actually equal to, how about 180 degrees? So that'd be pi minus pi over 6. Making sure we have the same denominator. That's 6 pi over 6. Take away pi over 6. Well, that's just 5 pi over 6. And look at that. Those are my two lovely answers. Okay, good review. Here's the spiciness. Let's see what happens when I now try to solve this question. Part B says sine 2x equals to 0.5. Well, same thing, I'm going to graph this out. Notice that 2 means it's a horizontal compression by a factor of 1/2. So instead of going from 0 to 2 pi, I now go from 0 to pi. So 0 to pi, everything gets cut in half, so there's pi over 2. And then between 0 and pi over 2 is where it equals to 1. Between pi over 2 and pi, that's where it equals to -1. If I graph it out, this is what it looks like. Okay, and because this question said solve algebraically over the interval 0 to 2 pi, I guess I have to repeat myself. So let's draw in another cycle. Okay, so there's the graph of y equals sine 2x. In this case, I still want this to equal to 0.5, so I'm going to draw that horizontal line. But now it looks like there are 4 answers. Okay, I'm not going to actually tell you what those 4 answers are here, because I just did a rough sketch. You could do this on your graphing calculator and find the intersection points to get the decimal equivalents. But I'm just actually going to go straight to the algebra. And I guess the question here is, how will I find out these 4? You heard me right. 4 answers. Well, let's do the algebra. Okay. Sine 2x equals 0.5. Okay, what's our first step? Get rid of signs, so I will take that sign and put it as a sine minus 1 of 0.5. Okay, now, solving this stuff from part A, what did we find? We found that there were 2 answers. It was either pi over 6 or 5 pi over 6. So ultimately, what I'm going to ask you to solve now is I want you to make 2x, the stuff on the left, equal to pi over 6, or 2x equals to 5 pi over 6. Okay? Because ultimately I'm asking you to solve for 2x, not x in this case. So that sine minus 1 of 0.5, what we did from part A, gave us these 2 answers. So 2x equals to either pi over 6 or 5 pi over 6. Well, the algebra is pretty straightforward here. Divide both sides by 2, so pi over 6 divided by 2 is the same thing as pi over 12. 2 pi equals to 5 pi over 6. I'm going to divide everything by 2, so that's 5 pi over 12. So there are my 2 answers. But wait, the graph says there's actually 4 between 0 and 2 pi. How come? It looks like pi over 12 seems to be just this first point. And this one over here is 5 pi over 12. So how do I find the other 2? Say something to me. Say something. What's the period? If you said pi, you are correct. Remember, because I have a horizontal compression by a factor of half, the period became pi. It's supposed to be 2 pi, right? Half of 2 pi is pi. Well, to get the subsequent answers, I guess all I need to do is actually add pi. So I'm going to ask you to make a note. Note. Y equals to sine 2x has a period of pi. So to go from here to my other answers, I guess I should take pi over 12 plus pi. And of course, that's just pi over 12 plus 12 pi over 12, which equals to 13 pi over 12. Ah, that must be my third answer here, the one that's right after pi. That makes total sense. And I guess I can do the same thing with my other answer. X equals to 5 pi over 12 plus pi. That's the same thing as 5 pi over 12 plus 12 pi over 12. That's 17 pi over 12. Well, there you have it. Your fourth answer. And that's how you get all the 4 answers. Okay? Because I shrunk the period, I have double the number of possible answers. Okay? Alright. Part C is very similar to part B, so I'm going to ask you to try it out on your own. I'll still do it. I'll just be really quiet. This is a horizontal compression by a factor of 3. So from 2 pi, I'm going to cut this into thirds. The period, of course, is 2 pi over 3. So 1 pi over 3, 2 pi over 3. So there's its ending. I guess I should graph this out. Guess I should use blue to be consistent as well. 1, -1, so and then halfway. I guess there's actually 3 cycles in this case. Okay, there's sine 3x. This equals to 0.5. Boop, 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 boop. 1, 2, 3, 4, 5, 6 different solutions. Okay, go find all 6. And remember, once again, from part A, we found this equals to pi over 6 or 5 pi over 6. So once again here, what I'm doing now is I'm making 3x equal to pi over 6, or 3x equals to 5 pi over 6. Solve for x in both cases, just like how we did in part B. Pi over 18. 5 pi over 18. Done. Our first answers, but what about the rest? To find the rest, we're going to add to it the period. So to find the rest, keep adding the period, which is 2 pi over 3. And of course, you stop when you reach an answer that's close to 2 pi. So in this case, I know there are 6 of them, so I'm going to have to add 2 pi over 3 twice. So I'll go x1, x2. Here's my third answer, x3. Pi over 18 plus 2 pi over 3. I'm going to write the same common denominator, which is 18. That's 6. I hope this is straightforward for you. If not, go ahead and review some fractions. x4 comes from 5 pi over 18, adding to that 2 pi over 3, which of course is 5 pi over 18 plus 12 pi over 18, which equals to 17 pi over 18. There's answers 3 and 4. It's 2 more. x5 would then, I'm going to take 13 pi over 18 and going to add 2 pi over 3 to that. Once again, just keep adding the period, right? I'm adding multiples of the period. 13 pi over 18 plus 12 pi over 18 equals to 25 pi over 18. Yep. And x to the 6. Hey. Oh. X to the 6. 17 pi over 18 plus 2 pi over 3. 17 pi over 18 plus 12 pi over 18. How about 29 pi over 18? And those are my answers. Okay. So notice that when you have a horizontal compression, we have actually more answers that come out, right? Because the cycle or the period is smaller, you get more repetitions, therefore more answers. Okay. I'm going to ask you to turn the page, and I got one more example for you, number 2. I'd like you to solve this one graphically and algebraically over the interval. So I'd like you to do the graphic one first. And once again, this is just a review of chapter I guess the beginning parts of chapter 5 when you graph this out. My suggestion is to separate this into two things. So graph out y equals to 2 sine pi over 4x plus 1 first, and then another equation, y equals to 5 over 2. Find all the intersection points, and there you go. And then otherwise, I'd like you to actually solve this algebraically as well. Okay? Go ahead. Just going to help you out by looking at y equals to 2 sine pi over 4x plus 1. I'm going to actually erase this 5 over 2 so I have some space to do some work. Here I notice a vertical expansion by a factor of 2. Shift up by 1. And this pi over 4 thing is peculiar. This is the b value, so it's a horizontal expansion by a factor of 4 over pi. Or if you think about the period, remember it's 4 pi times 2 pi, which is 8. Period's 8. Interesting. By the way, if that didn't work out for you, because you're not too sure what the heck just happened there, remember period, it also equals to 2 pi divided by the b value. In this case, the b value is pi over 4, which is the same thing as 2 pi times 4 over pi. Same thing, that's just equal to 8 pi over pi, or just 8. Same thing. Okay, so I guess I need to graph this out. I guess I need to make axes here. Let's start here. Let's go here. 8, right? 1, 2, 3, 4, 5, 6, 7, 8. And then, I don't know. 1, 2, 3, 4, 5. That should be okay. -1, -2. Alright, so why don't you start graphing out one cycle of y equals to 2 sine pi over 4x plus 1. Okay, I've helped you set up your axes. It's time for you to graph this out. Do these in steps if you want. So once again, I think if I were just to do the vertical expansion by 2 and a horizontal expansion with the 8, notice it starts at 8, or sorry, 0, halfway is 4, halfway is 2, halfway is 6. Expansion by 2 means you go up to 2, go down to -2, By the way, this graph in red is just y equals to 2 sine pi over 4x. Remember, we do all the expansions and compressions first. Then I have to shift it up by 1. I'll now use my blue to do that. So 1, 3, 1, -1, 1. So the blue is now y equals to 2 sine pi over 4x plus 1. I guess I can erase the red because that's really not part of the actual graph, so I'll erase that anyways. Bye-bye, red. Bye-bye. So there's my graph of 2 sine pi over 4x plus 1. And the other part of the equation is that 5 over 2. So I'm just going to plot that. 5 over 2 is the equivalent of 2.5 as a decimal. So, oops, not 2, but 2.5. Okay. So I guess my answers are here and here. Okay. All right. I'm going to just estimate what they are in this case. Looks like it's almost 1, maybe a little bit past 1, I don't know, maybe 1.1 as an estimate. This one seems to be pretty close to 3, I don't know, let's go, I don't know, 2.9 as an estimate. So by the graph, it looks like I've estimated my answers to be 1.1 for x, and 2.9. And these, of course, are in radians. Okay. All right. Let's see if you can actually get the same answers for me algebraically. Let's try. Okay. Here we go. Algebraically. I'll use purple. Going to copy the question again. 2 sine pi over 4x plus 1 equals to 5 over 2. Okay. First step, ladies and gentlemen. The goal here is to isolate x, so what should I move to the other side first? If you said subtract 1, you are correct. 2 sine pi over 4x equals to 5 over 2 minus 1. That's 5 over 2 minus 2 over 2, which is 3 over 2. What's next? If you said divide by 2, you are correct. So we have now sine pi over 4x equals to 3 quarters. Good. Now, our next step, is to get rid of the sine. So pi over 4x must equal to the inverse sine of 3 quarters. This, unfortunately, is not a not a special angle or from a special angle table. So just use your calculator to figure this out. Remember, radian mode. Okay, I don't have the degree sign. Asking for answers in radians. Okay. Bring out the calculator. Press on. Make sure I'm in radian mode. Oh, so close. I could have made a mistake. Inverse sine of 3 over 4. That equals to 0.848. I'm just going to round this to 0.85. Is that the only answer, dear friends? Nope. Because once again, sine is positive in quadrants 1 and 2. 0.85 radians is like in the first quadrant. So my answer in the second quadrant would be, yep, you guessed it. This angle would be pi minus 0.85. That's approximately 3.14 minus 0.85. How about 2.29? Okay. Now we're not done yet because this is equal to pi over 4x. So pi over 4x equals 0.85. And if I were to solve that, that means x equals to 4 over pi times 0.85. I'm going to use my calculator for that. 4 divided by pi times 0.85. That's approximately 1.09. Okay. And if I were to do that with the other answer as well, the 2.29, then that's, of course, pi over 4x equals to 2.29. I'll do the same thing, 4 over pi, 2.29. By the way, that singing is not me, it's my water kettle. Oops. It's finished boiling. So, back to my calculator. 4 divided by pi times that by 2.29, and voila, 2.92. Hey, these are the algebraic answers. And if you compare that with my graphical answers, whoa, that's pretty close. Yay. I like it when the picture matches algebra. It makes me feel good that there's still sense in this world. Okay, A little bit more, and then we're done. Hey, what if I said the general solution? Yeah, the general solution. So of course I've only found like 2 of them. But remember, the sign goes on forever and ever and ever, so what's the general solution? Remember, the general solution is always just your initial solution, and you're going to add to that multiples of the period. Recall once again that the period from above was equal to, what was it, 2 pi over b. b is pi over 4. I know you don't have to write this again. You did it before, so if you remember, it's just 8. That's great. So I'm just going to take my 2 answers from above, so the general solution would be taking my answers 1.09 and 2.92 and adding to that the period times n. So plus 8n, and of course n must be an integer. That is it. You're done. Part 1.